So we talk about the inequalities in general and also the linear ones today. This first part, it just tells you that if you have something else but equal sign there, then you talk about the inequalities. They say that they are conditional inequalities or absolute inequalities based on what kind of results you get. The one missing from here is that if you don't find the solution, for linear inequalities, it also can be the case, not very often, but anyway, it can happen that you don't have any solutions. But these are here just that you have a feeling that you have heard about them if somebody talks about this, but I haven't met this so often that we don't concentrate to them. What is very important, what I talk about here is true for all inequalities. It can be trigonometrical, it can be logarithm or whatever, but with all inequalities, you can always add the same number to both sides of the inequality. The number can be positive, it can be negative, and it doesn't matter because we are always checking whether the original truth value remains. So if we have inequality 2 less than 4, if you add +1 to both sides, it's 3 less than 5. It's still true. So it's possible. If you add -1 to both sides, it's going to be 1 and 3. It's still true. No problem at all. If you want to multiply with positive number, it can also be dividing. The same situation remains. So if you have a multiplier 3, this is going to be 6, this is going to be 12. 6 is still less than 12. No problem. If you want to divide by 2, you get 1 less than 2, still true. No problem at all. But if you do it with -3, you get a -6 and here -12. -6 is more than -12. So this statement is not true anymore. This is false. But if you change the sign, so if you reverse it, your statement would be -6 more than -12, then it's true. So whenever you multiply or divide with the negative number, reverse the inequality sign. This can be the first thing what you do because it happens every time. So with linear inequalities, the solution method is basically exactly the same as for linear equations. What you do, you transpose all the terms to the variable terms to the other side, constant terms to the other side. You divide with the multiplier and you get the result. So this is what happens here in the example 1. The only problematic part is here, when you are multiplying or dividing. Here, the multiplier is 3, it's positive number, so it's no problem. You can just divide and you get the result. Inequality sign remains the same all the time. And if you want to check your result, you, for example, take value 0, which is less than 2, put it here and put it here. The statement -5 less than 5, -1 less than 5. It's true. So probably our result is correct. If you want to double check, use, for example, number 3. Here you are going to get 5. Here you get 2. 5 less than 2, false. So based on this, we could say this result is correct. In example 2, it goes in the same way as in example 1. All the variable terms to the left side, constant terms to the right side. Simplify, and you get here. Multiplier is -3, so it's negative. The first thing, reverse the inequality sign. Then do the calculations, and you see what is the result. If you use the number 0 here, it says 3 more than 2, correct. If you use number 1, you get 1 more than 3, incorrect. So probably the solution is correct. These are the basic cases. The example 3 here requires a little bit more. The problem here is that we have 2 letters, A and X. The first problem is that based on what is said here, we do not know, do we solve it for A or do we solve it for X? So from this point forward, if you have this kind of case in your exercises, you can assume that you are solving it for X. In this case, A is called a parameter. It has a constant value, for example, 5 or -7. But at this point, we don't know what the value is. So when we start solving this one, we do it in the same way as we did in previous one. The only thing is that we have denominated those 2 and 3. So to get rid of them, we multiply both sides with +6. So we do not have to do anything for the inequality sign. Number 6 multiplies this one, so this is what is left. Number 6 multiplies this one, and this is what happens here. But you have to remember multiply also the 2, so you compare to the 12. If you don't want to do it, so if you don't want to multiply it, it's not a problem. You can divide them separately and do the calculations. You are going to have fraction numbers, but you are going to get exactly the same solution. I do this one because in my eyes, this looks easier because I have only the integers there. So after that, I open the brackets, I simplify. And as we agreed, or at least I agreed, that we solve it for X, we leave the X terms here on the left side and all the constant parts to the other side. So after that, we have something times X less than -6. And this something is the problem. If this one happens to be positive, we do not need to touch this one. If it happens to be negative, we have to reverse this one. And how about if it happens to be 0? If 2 minus 3a equals to 0, the whole left side equals to 0. And the statement is 0 less than -6. That is incorrect. So if this is 0, then there is no solution. So for a to equal to 2/3, the solution cannot be found. If it's something what is positive, so meaning that a is less than 2 over 3, in that case, you can just divide it and do not touch the inequality sign. If it's negative, so a is more than 2 over 3, in that case, please remember to reverse the sign, and basically you get the same result as here, but of course with a different inequality sign.